All right, I'm going to talk real quickly about number 16 and number 19 in chapter 4. Number 16 says the cable supporting a 2,125 kilogram elevator has a maximum strength of 21,750 newtons. What's the maximum upward acceleration that it can give the accelerator without braking? So let me draw a picture here. So we have a tension force going up, we'll call it Ft, and then the force of gravity going down, which is mg. Let's write down our givens. M is 2,125 kilograms. Ft is 21,750 newtons. So we can sum up the forces. Sum of the forces is equal to ma. So Ft minus mg is equal to ma. Ft is 21,750. M is 2,125. G, of course, is 9.8. M is 2,125 again. And we need to solve for A. So let me simplify this a little bit. 2125 times 9.8 is 20,825. So let's do some math. 2,150 minus 20,825 is 925. So this whole side is 925 is equal to 2125 times A. So divide both sides by 2125. And you get A is 0.44 meters per second squared. So that's the answer to number 16. And let me check that, make sure it's right. Yeah. And then number 19. So I'm going to erase this. It says a box weighing 77 newtons rests on a table. A rope tied to the box runs vertically upward over a pulley, and a weight is hung from the other end. So here's essentially what's happening. Here's the box. We have mg acting down. That's the weight of the box. We've got the normal force of the table acting up, and we've got the tension force of the cable acting up. Even though that force goes up over a pulley and then it's being pulled down, I guess we'll talk about that.
Nurse current, line 1, please.
So here's that tension force.
Line 1.
Ft is mg, and that's a different m than what we had before. But I think they actually tell you what that number is. They calculate it for you. They give it as a weight. So the box weighs 77 newtons. So mg is equal to 77 newtons. Determine the force that the table exerts on the box, which is the normal force. If the weight hanging on the box on the other side of the pulley is on letter A, okay, on A, we can say mg is equal to 30 newtons. So we can say Ft minus mg is equal to 0. So Ft minus 30 is equal to 0, or we can say Ft is equal to 30. And so if we sum up the forces here, so sum of the force is equal to ma. Ma is going to be 0. It's not moving. We can say Ft plus Fn minus mg is all equal to 0. We know Ft is 30 newtons plus Fn minus 77 newtons is all equal to 0. So 77 minus 30 is what it ends up being. We can say Fn equals 47 newtons. So this is A. Then on B, we've got the same equation, but they changed the weight on the end. So this is going to be 60 over here. So Fe is going to be, I'm going to say Ft on B is going to be equal to 60. I'm not going to go through all the math again. So I'm not going to rewrite this equation. I'm just going to put 60 newtons plus Fn minus 77 newtons is equal to 0. So Fn is equal to 77 minus 60, which is 17 newtons. And then letter C. Now the tension force is 90 newtons. So we can say 60 newtons plus 90 newtons plus Fn minus 77 newtons is all equal to 0. And what you end up with here, the normal force, is equal to negative 13 newtons, which means we can't really have a negative normal force. It means that since this tension force is higher than the weight, it's going to lift it up off the table, and there's going to be acceleration over here. So there's going to be an acceleration value, and we can say that Fn is no longer going to be, the table is no longer going to be pushing on the box, and so since it's negative 13, it's essentially, the Fn value is going to be 0.